This is chapter 5.4, Equilateral and Isosceles Triangles. Theorem 5.6 is the base angles theorem, which says that two sides of a triangle are congruent, then the angles opposite them are also congruent. The corollary 5.2 says that if the triangle is equilateral, meaning all three sides are congruent, then it is equiangular, which means all three angles are the same. Theorem 5.7 is the converse of the base angles theorem. If two angles of a triangle are congruent, then the sides opposite them are also congruent. The corollary to that is that if the triangle is equiangular, then it is also equilateral. When looking at an isosceles triangle, the sides are the legs, and the base has two base angles. So when they say the sides opposite to an angle, it means that this angle is the opposite of this side, and this angle is the opposite of this side. For example, in example 1, we have triangle DEF. If DE is congruent to FE, what can we conclude about these two angles? They're congruent. So we can say angle D is congruent to angle F. Find all angles in example 2. If this triangle has three sides that are congruent, that means all of its angles are congruent. If the interior angles of a triangle equals to 180 and we divide it into three equal parts, then that means each of these angles equals to 60 degrees. Let's make it a little more complicated. Looking at this picture, we know that angle K, angle KNL, and angle KLN are congruent because we have these lines, which also means that its sides are congruent. So this is 4. That means y must also equal to 4. I didn't mean to use yellow. It's a little hard to see. Okay. Which also means that NL is 4. Looking at this picture, since these base angles are congruent, their opposite sides should be congruent. So 4 equals to x plus 1, solve for x, subtract 1 on both sides, and x equals to 3. Short and sweet.